Hi, can you hear me?
Hi, yeah,
Cool. How are things going?
pretty good. How about with you?
I'm doing well, thank you. So, before we get started with this interview, I wanted to ask you a few questions to make sure that I ask you the right kind of questions.
Okay.
So, is this the first time that you're using interviewing.io?
No, I've used it before.
Okay. And what position are you applying for?
Um, so I'll be applying very soon for internships for next summer, software engineering internships. I'm a rising junior in college studying computer science.
Okay, software engineering internships and sounds good. And what kind of companies are you applying for internships at?
Um, I think generally like the larger established software companies, like all the FAANG companies, and similar kinds of like um, uh, large software engineering companies. I'm not necessarily as focused on going to work at a startup. I think at least for next summer, I'm aiming to just work at a more kind of like established, well-recognized company, and learn some great software engineering practices, and then maybe start my career there. Hopefully, if I can get a return offer. And
Mhm.
so that's kind of mainly what I'm focused on.
Sounds good. And have you actually gone through any interviews yet, or are you still preparing?
Not for this recruiting cycle, no.
Have you done so for previous recruiting cycles?
Yeah. I'm actually currently interning at a company called Yext, which is a software company.
Mm.
And yeah, so I interviewed for a bunch of companies when I was applying to stuff last fall.
Mm. How did that go for you? Not the job, but the preparation.
Um, it generally it went well. Like I think I was fairly prepared, but um, I think definitely I've done a lot more practice since then, and I was a little bit like um, definitely a little bit shaky on like especially the harder type problems, which I think this given that I'll be applying to probably more difficult like companies to get into, or to get an offer from. Um, those will probably be like more important this time, and so like yeah, but generally it went okay.
And how prepared would you say you are for this current interviewing cycle for these larger FANG type companies?
I think for coding interviews, I've been doing a lot of prep and I feel fairly prepared, but I still am a little bit unprepared for like behavioral interview stuff, and I don't know like if some companies do like system design, so I'll definitely be practicing that stuff as I start to like apply to places and hopefully get interviews. Um, yeah.
Awesome. Great. Thank you for that information. So I can help you, and let me give you some background about myself and the way my company does interviews and my advice for you preparing, and then the kind of question that I can give for you today. How's that
Okay.
sound?
Yeah, sounds good.
I work for a large FANG company in Seattle. I've been working there for 7 years, more than 7 years, and I have specific experience with helping interns at the company and interviewing interns. So with these large FANG companies, fortunately or unfortunately, a lot of the process is automated. So you'll go through some automated phone screens, and believe it or not, at this company, automated behavioral questions. And if you pass, and you get an offer. But if you don't quite pass, there's a human who intervenes to give you additional interviewing. Um, so at the large FANG company that I work for in Seattle, there's an equal emphasis on uh, data structures and algorithms in terms of coding, 50%, and 50% behavioral questions. And you can't pass if you don't have either of those. So when you said that you're prepared for coding, that's great. You should be prepared for behavioral as well, at least from my company. And I would suggest for university students, they feel like they're disadvantaged because they don't have previous experience. But it doesn't work out like that. And I suggest you get specific practice on interviewing.io with me or anybody else for behavioral.
Okay.
And at least at my company, interns and entry-level SDEs are not expected to have system design experience, nor are they evaluated on it. They do evaluate you on object-oriented design, so like how to organize code, but not system design. And it may be different at different companies, but not. This is how my company does it. I
Okay.
wouldn't worry about system design.
Yeah, I'll definitely, I guess, start scheduling some like behavioral interview practice in that case.
Yeah. Um, yeah. That's all I can say. But for the specific sessions, what you paid for is data structures and algorithms. I can help you with that. And you, so I'm guessing you're probably preparing by going through lead code. What other resources are you using?
Yeah, generally going through LeetCode. I actually started out on a different service called Algo Expert, which turned out to be not as good as LeetCode. But yeah, so I'm just doing kind of practice problems, doing interviewing.io. I went through Cracking the Coding Interview, the book, which had some helpful kind of like information and like practice exercises. So yeah, that's mainly what I've been doing.
Cool. So that's great. I'm going to delete the code here. It's not very useful. I also suggest a book called Elements of Programming Interviews. I really like this book. I recommend getting it. And besides this, what language were you planning on interview? Or what language do you want to interview in?
I usually interview in Python 3.
Okay. So, and Python 3 is fine. Usually for FAANG companies, if you have time, I would suggest interviewing in like one of those boring big languages, Java or C++. But if you don't have time, Python 3 is fine, and nobody looks down on you, and nobody really cares what language you use. It's just that in Python, unfortunately, sometimes the idioms are so powerful that you can solve interview questions without necessarily having much algorithms and data structures and object-oriented programming knowledge, and some interviewers may count it against you. But
Okay.
you have to weigh that against the fact that you would have to learn Java or C++. And so I would suggest sticking with Python 3, but just be aware, stay away from the standard libraries or too much cleverness, especially if a question calls for data structures and algorithms.
Okay. Yeah, I am.
Sure. Sorry.
Yeah, I'm pretty familiar with Java, but I've been doing practice in Python just because I guess I found that it's like easier to write like more concise code in an interview setting. But I'll definitely maybe try some practice in Java and see how easy it would be to transition over. Because I guess that makes sense. And like most like software engineering internships or jobs, you're not really going to be doing much programming in Python, given that it's highly inefficient. But
I don't want to take up too much time with this.
okay.
Python is very, very appropriate for some roles, especially for research scientists and machine learning roles. It's it's mandatory. But at least at my company, the large FAANG company that I work with, 90% of the software is written in Java. There's a renaissance in Rust, but it's mostly Java. Python, inefficient, yes. It's just that it's easy. I don't know. Java is very common in the industry, but in an interview, nobody cares what language you use. It's just like in Python, there's things like the bisect module. Like, don't use that. Just as a silly example. Just like don't use too much standard library, or clarify if you can use it. That's all.
Okay.
That's it. Cool. And that's all the advice I had. So how about we get started with questions? Unless you have any questions for me.
No, I think I'm ready to go with practice questions.
So what I'm going to do is just give you some regular phone screen data structures and algorithms questions.
Okay.
And so the bar for these questions so this is very common at companies. So for a phone screen, the goal is to determine if somebody should be allowed to go to an on-site. Would they just flounder, or do they have a reasonable chance of success? It's not, the bar is not will they be a good intern at this company. Then there's a subsequent round, the on-site, which has more intense questions.
Okay. And in the on-site, I'm guessing that's when you do like whiteboard questions.
In this day and age, in my experience, yeah, over a video conference, whiteboarding just doesn't work. Some candidates come with whiteboards and they struggle to draw things. It just doesn't work really. But especially as an intern, you won't be expected to do system design, so you won't be whiteboarding anything.
Oh,
so
cool.
often you can get away with just an interactive code editor. So I wouldn't worry about that.
Okay, sounds good.
If you're more experienced, that's far more difficult. But let's start with a simple question. And so for a phone screen, you should expect 2 coding questions, each one lasting 25 minutes. And I'll make a note of the time on the right-hand side.
Okay.
For on-site at my company, for interns, okay, this is more tricky. Interns is far more different. Often the loop is very small, so often you'll only have 1 or 2 interviewers, and it'll still be 1 hour each, and they will evaluate you on behavioral and coding, but it'll just be 1 or 2 rounds, not that long.
Okay.
Cool. So let's start with the first question. I'm going to just paste it here. Also, the final piece of advice I'd give you is for internships, when you do the automated code screens, you will have an environment, at least at my company, where you can run code. So on the one hand, that's great, but at these large FAANG companies, when you get to a in-person phone screen or an on-site, you won't have the ability to run code. So my advice is not to rely on the code runner during and as you're practicing.
Okay. All right. Yeah, sounds good. So looking at this question, I think given that the array is sorted, we're looking for a target integer. I think the right strategy will be binary search to find one of the elements that matches that target.
Mm-hmm.
And then I believe just going to the right as much as possible from that point to find the last index, and going to the left as much as possible to find the first index would be the most efficient strategy. I don't think there's, because once you reach the section where it's just presumably like a bunch of matching integers, like 1 or more, then there's nothing really, the sorted property kind of isn't really useful anymore. And I think at that point you just kind of have to do a linear search for the first and last indices. But certainly to find that section of elements matching X, the binary search will make it much more efficient to get there. So
for your proposal is to find the section of integers using binary search and a linear search left and right. What's the time and space complexity here for proposed solution?
So I guess in a complete worst case scenario where like you have O of n like matching integers, it would just be O of n. But in the case that there are, in the expected case where you don't have a bunch of matching integers, it would be O of log. I guess it would be like O of log n plus like O of x, or O of like I don't know, m, if m is the number of like integers matching x. So yeah, that's kind of that would be the running time, and then I think this can be implemented with just constant space because we don't really need we can do an iterative binary search, and we don't need to
Mhm.
store anything in any data structure or anything like that.
Mhm. So focusing on this case where you may have a long run of the same integer x, um, is there any way of avoiding the linear search?
Um, yeah, that's a good point. So um, I suppose okay. So I think actually if we try and find like the closest element to x that's like strictly less than x, which we can also do with binary search,
Mm-hmm.
um, and we store the index of that,
Mm-hmm.
um, then we could use that to like that would be like on the left side of the string of matching elements, and then you can do the same thing to get to the right side. But I guess it's still problematic in like thinking about the absolute worst case because you could have like a long string of those of that element that's like less than x.
Mm-hmm.
But um, so yeah, I think um, but actually okay, so I think once you find like an element matching x, um, you can kind of do a binary search to find like the left side and right side, I think, because you can like I guess like go halfway um, to like the left side of the array, see if that still matches x. If it doesn't, then you've gone too far to the left, and then you can go to the right. So you can kind of use that a different sort of binary search to find the left side, and then same thing to find the right side.
Mm-hmm.
And that would use it um, to just log in running time.
Mm-hmm.
Um,
So
so
what I think would be great for this question is let's try to keep it login, and let's see if we can figure it out.
uh, sorry, you said let's try to keep it plug in.
Let's try to keep it logarithmic and see if we can figure it out.
Okay. All right. Yeah, sounds good. So I think that strategy would keep it logarithmic. And so yeah, I'll first write uh, so I guess we're given an array integer x. So yeah, so first to find like one of the like an index that matches x, we'll just do kind of like a normal binary search. Um, so yeah, I guess we'll say left is 0. Um, actually, so if the length of the array is 0, then in this case, like I guess, and this will come up later also. If x isn't in the array, I'm guessing we should return none or some sort of or raise an exception or something like that.
Well, that's a great question. Maybe if we decide x is not in the array, we can return minus ones.
Okay. Um, and all right, so now I'll maintain kind of a left and right pointer. So left start at 0, the left side of the array, and right will start at the last index in the array. So I'll say while left is less than or equal to right. Let's see. So I'll make a pivot equal to left plus right integer division by 2. And then I'll say, so if array pivot equals x, then I'll just write out the cases first. But this is the case where we found X. I guess say element pivot array pivot. So or maybe pivot element. So if pivot element equals X, else pivot element is less than X, then we want to go right, and then else we have pivot element is greater than X, and so we want to go left. So yeah, in the case where it equals X, this is where we want to then do our binary search to find the left and the right side. So I think we should probably split this out into a helper function. So I'll say like find left. So this will like find the first occurrence of the element at the given start index, and then maybe find first would make more sense, and then find the last occurrence. And these will look probably pretty similar, but they'll be going in different directions. So I think it'll be like reversed logic. But yeah, so we'll basically say in the case that we find X, we'll return find first array pivot, and then find last array pivot. In the case that it's pivot element, in the case that we want to go right, we'll just say left is pivot plus 1, and if we want to go left, we'll say right is pivot minus 1. And we have to take care of the case where, I guess where, so if left and right are equal, then you could have this case where pivot will just equal like left equals right, and then I believe, but actually I think because we plus 1 and minus 1 here, like in any case the pivot will change. So I don't think we can actually get to that stationary point where pivot is never changing. So I think no matter what, like like because the difference, or I'll say like because right minus left strictly decreases at each iteration, or we return. I think we can. We can probably implement the find first and find last functions now. I think this is basically everything. Besides, at the end, if we don't find, like if the while loop terminates and we haven't found the element yet, then we can return -1. Okay, so for find first, so I suppose, and actually, we could probably even make this more efficient by maybe like storing like the rightmost element that's less than. This wouldn't. I don't think this would change the overall complexity, but it would make it more efficient. If we stored like the rightmost index where the element at that index is less than our target, and the leftmost index where the element of that index is greater than our target, and then that can kind of bound our search here. So like find first, array start, and then like left, yeah, basically like a left bound.
Oh, I see.
Um, sorry, left.
And so this idea of having left or right bounds wouldn't change the overall complexity, but might make it faster.
Yeah, like if I guess, well, I mean, maybe it's not even worth the extra, the kind of extra effort to maintain those variables, because honestly, like it, so it would only help, I guess, if you happen to, I mean, in pretty much any, like in a normal binary search, like because it's logarithmic, it's not going to take very many iterations to like get to the target. And so like, I guess like having, storing that like that last iteration where you were to the left, and like the last index where you were to the left and the last index where you were to the right, like that would cut out like a few initial steps that it took to get there. It would cut out like reproducing those, but I mean, maybe it's something like an optimization where like in practice you would want to like actually just first do it simply and then try out the optimization, see if it actually helped. Like maybe updating the variables in all normal cases just wastes more time than it helps, and then like go with that if it does actually help in practice. But I don't know. I guess because this is like a kind of small optimization, maybe I can just implement it first and then maybe add that later if yeah, if we have the time, or in practice, like if it actually, we would try it out and then see if it helps. But all right, so I guess yeah, to start, I'll just implement the basic logic here because we need that to be able to solve the problem. So I'll say left equals 0 and right will equal start. So I guess we want to say like we basically want to find the spot at which it changes from an element less than like our target to the target. And so I think at each like step of the binary search, we want to look at the element and we want to look at the element to the right. If the element equals, if the element still equals our, or I guess like, yeah, the element and the element to the left. If the element to the left equals like something less than, or I guess in the, like to start, if the element equals our target, then as a subcase, if the element to the left is less than the target, then we know we found the left bound, or like the first occurrence. If the element to the left is the same, then we need to go left. So yeah, I guess our cases are like, let me say target equals, since this is kind of like an internal function, like I won't add like input validation or anything like that. Like I won't check that start has to be in range. And like besides, I guess the first time we index into it, it would throw an exception if it were out of range anyway. So, so yeah, like basically the target will just be array start, and left equals 0, right equals start. So I guess we'll have I mean, for now, I'll just say like while true, we might update these, but I think the main, like we basically, we know that eventually we'll break from this, and it's not like this loop where you might terminate the loop, like left might be greater than right, and you haven't found anything, because you know that like you're looking for the first occurrence of start, and so start could be the first occurrence, and if there are no elements to the left, then it is. If there are any elements to the left, then you just choose those. So like in all cases, we will return a valid answer for this function. But anyway, so I'll just reproduce that logic I was discussing.
Yep.
So like if so I guess like first, yeah. So if array, let's see, like pivot equals left plus right, same thing like as the other loop. And I'll deal with like the edge cases later, but for now I'm just like the main logic. So if array pivot minus one is less than, or sorry, if array pivot equals target, if array pivot minus one is less than target, then return pivot. Then so if it equals target, then we want to go left. And those are the only cases because it's a sorted array. So yeah, so in this case, like right equals pivot minus one. And also, like, I might update this when I deal with the edge cases, but yeah, for now, I think this is good. So like else, array pivot is less than target. That means we're too far to the left, so we want to go right. And so like left is pivot plus one. And so there are some edge cases like if we somehow reach like the left side of the array, which is possible, it's like we just want to return the current index. So like if pivot like equals 0 basically, which is the only case where pivot minus 1 would be out of bounds, then we just want to return actually wait, if array pivot equals target, just return pivot, else you else I guess like because we've only gone left, I think this is actually an unreachable case. So like because we have this invariant that the array is sorted, and we've only gone left in this process, I think we can actually just return the pivot in this case. I'll add a comment saying like we know that so return the pivot in this case. Return 0. So now I think I'll replicate this for find last. It should be pretty similar, but with kind of reverse cases. So now left is start and right is length array minus 1. Same thing here, except if pivot is length array minus 1, then same thing, we return, I guess in this case return pivot. Just be consistent. If array pivot equals target, then, so in this case we actually want to look at pivot plus 1. So if array pivot plus 1 is greater than target, then we return pivot. If array plus 1 equals target, then we want to go right. And then else we want to go left, because like if array pivot is greater than target, then we know we've gone too far to the right. So, and I think that should be the main logic. So to justify that this loop will always terminate, we can kind of use the same. So I guess just to be careful, like if pivot, like the only stationary point of pivot would be if left equals right. And yeah, I guess looking at all these cases, in each case, either left moves strictly to the right or right moves strictly to the left. So you could never have that kind of like stationary point of left and right being equal and never changing.
Yep.
So yeah. And so I think that should be all the logic. I guess, should I write some test cases or?
Could you go through an example?
Okay. Yeah, so I guess I'll go through maybe this one, and just below it I'll write the index number just for. Yeah, so down here looking at this example, so in this top level function, length of the array is not 0, so we won't return in this case. So we'll say like, I guess I'll keep track of like left and right in each iteration. So like first left will be 0 and right will be 6. Then
actually, I wanted to give you enough time for the second question, so I think that this code is on the right track, and I wanted to go on to the second question, if that's okay.
Okay. Yeah, sounds good.
So I'm gonna delete this text. I'm going to paste in a problem description at the top.
All right.
So I'm just gonna quickly switch to plain text. I'm gonna paste it in. I'm gonna switch back to Python 3 and delete this useless text. Okay.
Okay, so sample will select a random string.
Yep.
Okay. Yeah, so and I guess like yeah, so I'm assuming we kind of take the string as like we want a uniform a uniform sample over the current set of strings. So like even if you add like two identical strings, that shouldn't bias the sample towards that string, right?
Yeah, correct.
Okay. So I mean, I think using a set obviously would allow for adding and removing, but I guess the trick is how to kind of maintain it so that you can select at random. So, I think, I mean, ideally, like I guess the issue is like we can generate like a random number, but um, in a hash set, I guess there's no ordering, so there's really no efficient way to select like a a string corresponding to like a random number.
Mm-hmm.
Yeah, certainly not like uniformly across all the existing keys in the set. So I think actually, my initial thought is like if you maintain like a tree um, of the strings, that would kind of afford like logarithmic add and remove,
Mm-hmm.
and then there should be a way to um, do like a logarithmic sample. If you, I think like, I mean, if you maintained like if you augmented the tree with like the number of nodes rooted at each node, um,
Mm-hmm.
then like at each step you could kind of generate a random number and then like have the threshold be like proportional to the sizes of the left and right like subtrees. So like if the left subtree had like two nodes and the right subtree had like four nodes, um,
Mm-hmm.
then you would want the cutoff of your random number to be like 2/6. So if the random number fell below 2/6, then you would want to go to the
Mm-hmm.
left, and if it was above 2/6, you would want to go to the right. So that would be like logarithmic for all the operations. And
So,
I
what if we wanted a constant time approach?
yeah, you mean constant time sample?
A constant time for all the operations.
Okay. Um, so I guess the only way to have a constant time like set implementation would be to use like a hash set. So I guess um, hmm,
That is true. Yeah. What you're saying is like, if I want to be able to um, track a unique set of strings in constant time, I need a hash set. Let's focus on that. What other ways could you have a constant time add or remove whilst maintaining uniqueness?
um, you mean like not using a hash set, just another kind of strategy or data structure for holding these strings in and affording add and remove?
Yeah,
Um, so, hmm. I mean, I guess like to have constant time add or remove, like you could use something like an array list or something like that, or
mm-hmm.
um, but I guess the issue is like you don't know when you. I guess yeah, that's constant time add, but it's not. Yeah, I mean it's not really. It's like you don't know if they're duplicates, and also when you remove, if you have to remove from the middle of the array, it's not constant time. If you had
Let's
like
yeah, let's focus on that. You're precisely correct. So you have an array list. Yeah, it's amortized constant time adds, and you don't know when there's duplicates, and you don't know when you remove if it's in the middle or not. So what could we do about each one of those problems? Let's focus on the first one. You said we don't know whether it's already there or not. What could we do about that? If we had an array list.
oh okay, so yeah, I guess we could map like um we could maintain like a dictionary or like a hash map mapping the string to the index in the array. And then I guess to remove, so to remove you could like swap it with like the last element, I guess, and update the last element's index and update the the element that you just swapped to the end, or I guess since you're removing that, just delete it from the dictionary, the hash map, and pop from the end of the array. And then
what difference does it make? Why can't I just remove it from the middle of the array? Why do you have to swap it to the end?
It doesn't. Well, okay, so I guess the reason why is because under the hood, like an array list is like implemented as an array, and then like you have this not necessarily invariant, but like you have this capacity, or you have the capacity of the array, and then you have the actual size of the list, which is the number of elements, and you have this invariant that all the elements up to like from index 0 to index size -1, that all those elements are in the list, and then everything beyond that is not in the list. So the way that it's implemented requires that like all those like if you just remove from the middle, there's no way in an array list to just like remove that from your list, unless you like the only ways to remove something is effectively to just decrease the size variable, and so it has to be like that last element for you to be able to remove it efficiently.
Are you saying you can't remove elements from the middle of a list, or you can't efficiently remove elements from the middle of a list?
Yeah, I mean, you certainly can. You could remove it and then shift all the elements, but I guess in our case, since we don't really care about the ordering in the list, it would be more efficient to swap with the end and then just reduce the size variable, and then we still have that amortized constant, because like sometimes we'll have to do O(n) work to shrink the array, but we avoid that requirement of doing O(n) work every time to like recopy the elements and shift them over to the left.
Okay.
So I mean, I guess to implement this, like, so I guess as like a class, or like I'll just copy this from this interface, like sampler, and so I'll have this add and remove and sample. So we're going to want to have like a string index hash map, and we're also going to want to have a like an array. So every time we add, we want to say like if item is not already in the hash map, then append it to the array and say update the hash map to to have this like last index. And if it was already in the set, then we don't need to do anything. To remove, in this case, we want to check if it is in the hash map. Then in this case, we want to say, so I guess let's first get its index, and then we want to say, we want to swap it with the last element. So like index comma, that's like the the element we're interested in and the last element, and then we just swap them by reversing this. And then, so now the element we're, and actually, sorry, we need to say self.strings to index strings array like index equals index now, because previously this element had the was in like the last index. So yeah, so now that's updated, and we can say just delete strings to index item and just pop them from the array. So this maintains like these data structures, and so I guess in the remove we could do, if the item doesn't exist, I guess should we return? I guess remove is void. So I'm assuming it's fine to just ignore in the case where you remove and it doesn't exist.
Yeah, let's say in this case we don't mind if it doesn't exist and we call remove.
Okay. So for sample, now we just need to, I guess, select a random element in the list. So I guess this would be like, let's see, I'm sure there's a random number generator in Python.
Yeah, you don't have to get the syntax exactly correct. You can pretend that some library exists and use it.
Okay. Yeah, so I'll just say like random, like just assuming this.
Sure.
Like assume this just returns and so we would just say like, so random times, like, I guess we need to be careful because we're mapping this random float onto integers, and we want to make sure it's still uniform across all the indices. So I think it would be random times like the length of the array, and then we would want to floor, actually, maybe like, yeah, like if we somehow just like did like, so index is random times length of strings array, and then like if index is len of, oh, and I guess like if we haven't added any elements for sample, should we like return none or throw an error?
That's a good question. What do you think we should do?
Well, I think since you can probably store elements, you can store none elements, or I mean, I guess like string, technically none could be considered a string, but maybe the better thing to do would just be in the add and remove, just make sure that item is not none, and then in sample return none to indicate that it's that there are no elements. I mean, I think it's probably better to like just raise an error in that case.
Okay, let's do that.
So, yeah, so I'll just say like, yeah, assert the length is greater than 0, and then here like, and I guess for remove it doesn't matter because none won't be in the it won't be in the hash map anyway. So and I guess we've kind of been following the pattern that like remove, we don't care if the element doesn't exist in there. So So if index equals like the length of the string, then we just want to say index minus equals 1. And I think this effectively means we're like basically pretending as if random like in like the range like 0 to 1, but with 1 being closed. And so now we can just say like or I guess math dot for index, and then we just return so yeah, basically, I mean, the reasoning here is like this number will be like, it'll be a random float in the range 0 to like length strings array. And so we just want to make sure, like flooring to get the index will give like a uniform sampling of like the integer indices, as long as we just prevent the like basically 0 probability case of it being exactly equal to length of strings array. And so in that case, we just like we do or like, yeah, I guess we can say like int index is just like length minus 1, and then else do this. So now like now int index should be a random number in like 0 to the length minus 1, which is what we want. So yeah, I think that should be everything.
Yeah. Can you go through your code with an example?
Yeah. So like if we were gonna put in if we were gonna insert like I don't know, the string like a, then that would cause, or like add a would cause strings to index to be like a to 0, and or I guess like strings array would just contain a. And then if we like added a again, it would do the same thing. But yeah, to walk through the code, like what would happen in the code, like, well, yeah, let me just leave. So it would assert that like item is not none. This if statement would return true because a, in the first case, a isn't previously in the map. And so it would append a to the end of the array, which is why we get this, and it would set like, it would map a to length of the array minus 1. So 1 minus 1, which is 0. So that's why we get this. And then in the second case, it wouldn't change anything because this if statement would item like a is now in the key set of string to index. So this would just skip and the method wouldn't do anything. And then like if we added another one, like by the same reasoning, it would not be in the map, so it would append it, and then it would update the 2 minus 1, which is 1. And then so I guess like if we removed if we removed a now, to show like swapping logic. So what it would do is it would first like I guess I'll just show like with an arrow. So it first would set the array to be this, and then it would pop off the end and set it to be this, and it would just remove. It would set the index of b to be what the index of A was, so 0, and it would just remove A. So now we have basically the same thing as for like A, but except B is now the only element in there. And then I'll just like go over the sample, like I guess, or before we remove, just to show the sample, it would say like index is random in like this range.
Sure.
And then like index is random so in this case this is like 0 to 2. Index is random in 0 to 1, but like the integers. And so we like randomly choose between A and B, which is the desired functionality in that case.
Yep, makes sense. Okay, cool. Yeah, thanks. So those are my two questions, and I've left some feedback in the notes, but I'd like to go over my feedback quickly.
Okay.
So for the first question to do with finding the start and end of where an integer appears, like you're very knowledgeable about time complexities and binary search, I liked your problem-solving style where you flesh out the high-level approach. You put paths everywhere. You refactor into help methods. You were able to talk through trade-offs. So like when you were trying to input optimization, which wouldn't reduce the time complexity but would make it faster, we talked through it. But something I noticed about that question and this question as well is you need to be a bit more ruthless about how much time you have. So
okay.
Once you identify the solution which targets a given computational complexity and the interviewer agrees with you, for optimizations, I would defer it. You can even leave to-do comments in your code and just be very focused on it and avoid being sidetracked because you didn't have enough time in the first question to walk through with an example. But
right.
But still, you're able to talk through trade-offs, and I liked how you were very concerned about whether pieces of code would terminate or not, or what invariants they had. So, especially for a phone screen, the first question you did very well. And then the second question to do with sufficient sampler, you talk through a lot of different interesting proposals. I liked your tree approach and with especially keeping track of the number of children nodes and then using random sampling. That's the first time I've heard it, and it's clever. But try to focus on the problem statement. Often this will save you time, pun intended. Like it says all the operations must be constant time. So it's tricky because in interviews, yes, the interviewer is evaluating your knowledge of data structures and algorithms. It's true. And so I think our discussion to do with the tree approach was very interesting for me. But the downside is it reduces your time for solving the problem and then going through it with a test case.
Right.
So
okay.
I think you have very strong abilities to discuss different approaches and evaluate different time and space complexities. And you come up with very interesting algorithms. But use the problem statement to focus only on a subset of approaches that are acceptable. And don't try to use it as an opportunity to boast about your knowledge.
Right.
That being said, there was one point where we were discussing how lists are implemented in Python, and your explanation was okay. And actually, my knowledge of lists in Python might not be what I thought it was. I think I left a note saying you were wrong, but I think I was wrong. But so I have two comments about that. One is when be very familiar with how data structures are implemented in your chosen language, whichever it is. But at the same time, I wouldn't focus on it, even if the interviewer wants to draw you into a discussion. Like the swap and pop approach, like whether the underlying array data structure decreases in memory or only increases in memory, it's not important. But I guess with both the questions, focus on computational complexity of the data structures and know how they're implemented, but don't focus on it in the interview, if that makes sense.
Okay. Um, yeah, I to be honest, I missed that that it had to be in constant time. So that's something that I guess is you know, more carefully read the question. Like I guess once I understood like the operations that it wanted, I assumed that I understood the question. But yeah, I guess that constraint that it had to be in constant time definitely would have saved me time from, not having to consider that tree possibility. So and then yeah, with the list, I guess I did feel like I was kind of not making the clearest explanation of that. But I guess the way I think about lists in Python is just as array lists in Java, like because you can.
Yep, that's exactly the way I think of it. I was doing research. It's not exactly the same as array list, and like even as I'm saying this, it's like, especially for a phone screen, don't get drawn into it. For an on-site, it's different, but for a phone screen, it's like how are lists in Python implemented? Don't get drawn into it. Just come across as polite, but just try to say like, listen, let's just, would it be okay to assume that removing an element from the end of the list is O1 time, and then it's amortized, and like it's amortized time to grow an array, because I think it's the same as Java.
Right. Okay.
Because the more you have very strong knowledge and you're able to use it to have interesting discussions, but it reduces your time to deliver working code and then to walk through it with an example.
Right. Okay.
Your approach is to explain the time and space complexities ahead of time, and that's fine too. But something the interviewers try to check off in their mind is, do I have code I can copy paste into an internal tool? Did they give me time and space complexities? Did they walk through it with an example? Did they go through edge cases? And so like that's the checklist they're going through.
Okay. All right. Well, yeah, that makes sense. And thank you for the feedback. I definitely felt like I got a lot of new knowledge that I hadn't had before from this interview, like as far as like practices, interviewing practices at FAANG companies, and all these feedback items are very helpful. So thank you.
You're welcome. Yeah, I think your preparation is definitely on track. Definitely go for the Elements of Programming interviews book. Definitely do some behavioral interviews, maybe at least two. Cracking the Coding interview has an excellent explanation of how to prepare for them. So use that first, and then do one or two practices on interviewing.io, and don't worry about system design.
Sorry, don't worry about what?
System design.
Okay. Yeah. All right. Yeah, that makes sense. Thank you.
You're welcome. Okay. Have a good day.
All right. Yeah. Have a great day.
Thanks. Bye.